Welcome to Algebra 2, Semester 1, Unit 1 Study Guide. This is in preparation for the Unit 1 exam. On the first page, you will notice that these vocab terms are matched exactly with their definition, right in order. So if you just go down and list this A, B, C, D, E, F, G, clear down through all the letters, then you'll be able to see which one is matched to which. I suggest that you study how you learn best in doing these through all the different units. You've got 6 units to practice before the final, so I suggest trying flashcards with one, try audio recording with another, try visual recognition on others. Talk to me if you need some other suggestions. Main thing is you need to be studying these about 15 minutes a night throughout the unit to make sure that you get them down. Okay, let's get into the problems. These are all a review from the unit, so if you have an issue of not understanding one, see me or come in and we can work on some extras, or you can talk to other students. First thing is performing the indicated operations. Number 1 is multiply. The rule is in multiplying or dividing, 2 negatives make a positive, 2 positives make a negative or make a positive. And so I just say if the signs are the same, it's going to be positive. If the signs are different, a negative and a positive, then it's going to be negative. So in this one, it's a negative and a positive, so I know that it's a negative 40. In the next one, it's a division, so same rules apply, and they're 2 negatives, so it's going to be a positive. 8 goes into 48 6 times. In addition and subtraction, if the signs are different, you subtract. If the signs are different, subtract and give it the sign of the number that is farthest from 0. So we would subtract these. 32 minus 14 will end up being 18. And the sign that's farthest from 0 is the 32. It's a positive, so it's a positive 18. On these, I oftentimes will add the opposite because the 2 negatives end up making a positive. I look at that as a distribution, -1 times -15, or I just say I don't subtract in algebra, I add the opposite, which will result in 21, positive 21, because their signs did end up being the same. Okay, a square with a side length of 8. And we're looking for the area. Well, area of a square is side squared. So area equals 8 squared, which equals 64 feet squared. A circle with a radius of 5 meters. You really need the formula for the area of a circle. The formula is pi r squared, r being radius. So we say the area is pi times 5 squared, which is 25 pi. And then we still put the measurement meters squared. Okay, we just leave that pi in there. It's the most accurate of the expressions. Write an expression to fit. You have $25 and you buy our raffle tickets for $1.50. I showed this in the notes real closely. Go back to the very first section if you need some help on this. 25 minus, because you're paying for these raffle tickets, they're $1.50 each, so you take $1.50 and multiply it by the number of tickets that you buy. And that is your expression for the money left. Okay? solving these problems. Again, I'm just going to hurry through them because you've already been taught them. This is simply a review and you're checking your answers. Draw the line down. Write your PIMDAs off to the side. Going up the PIMDAs because we're solving for that creepy dude right there, trying to get him alone. We have to keep this balanced. Whatever we do to one side, we do to the other. We see that we're adding 12, so we need to subtract 12 to get rid of that. That wipes out. We have 4/3. X equals 8. Now, in order to get rid of a fraction being multiplied by your x, you can multiply by the reciprocal. That's the same thing as dividing by that fraction. So that would wipe out. We would have x equals, this is 8/1. 4 goes into 8 twice. 2 times 3 is 6. Please rewind the video and follow through my instructions on these, pausing as you need to. I'm just going to fly through them. I would prefer that you have this entire study guide done before you watch the video. So go ahead and stop right now and do that, and then come back and check your answers. Here we would clear parentheses before we do anything else, so it's a negative 4x, we're just distributing, minus 10 equals negative 2x minus 16 plus 4x. Now we use the commutative property and put our like terms together. So we have a negative 4x minus 10 equals negative 2x plus 4x minus 16. Combining those two, we would have a 2x minus 16 equals negative 4x minus 10. Now we'd subtract 2x from each side to gather our creepy dudes together. So we end up with that wiping. I'm going to move this problem up here. Negative 6x minus 10 equals negative 16. Draw the line, write your PIMDAs, solving for the creepy dude. There he is. He's got a minus 10 next to him. Now realize this minus 6 is not being subtracted because it sits right next to the x. It's being multiplied. It's when the minus is between the number and the x that it's being subtracted. We do add subtract first. So we add 10. That wipes. We get negative 6x equals negative 6. X equals 1 because we divide by negative 6 on each side. Now remember, you can check these answers by plugging that value back in to the original equation, and the equation will prove to be true. Draw the line, write your PIMDAs. Going up the PIMDAs, trying to get this creepy dude alone, we add 55 to each side. That wipes, we get 6x. That's two opposite signs, so we're truly subtracting, giving it the sign of the larger. So that would be positive 42. Divide by 6 on each side, we get x equals 7. Here we have a couple options. We can add 1/4 and 2/5, or we can clear the fractions by multiplying everything by the common denominator. I showed you how to clear the fractions in the lesson. This time I'm going to go ahead and add the fractions. 1/4 plus 2/5. My lowest common denominator would be 20. 4 times 5 is 20, so 1 times 5 is 5. 5 times 4 is 20, so 2 times 4 is 8. We add those and we get 13/20. So we have 13/20 x equals 26. Now to get x alone, we multiply by the reciprocal. On each side of the equation, that'll cancel. We get x equals 13 will go in there once, 13 in there twice, so we see that x equals 40. Okay. Next problem. We want to gather the x's to one side, so subtract 6x from each side. That'll cancel it on that side, and we end up with negative 8x plus 9 equals negative 7. We subtract 9 from each side, we get negative 8x equals negative 16. Divide by negative 8, and we get x equals 2. Okay, end of page 1, or page 2. Page 3, remember when we get to the complex inequalities, I want you to look at this. If it's all connected, you know that it's what we call the hug. So go right to the graph first thing and fill in an open circle, because that's a less than with no equals. So an open circle, a closed circle, and connect them, because you know that it's going to be the hug where they're connected. Now we can solve for what those numbers are underneath there. This one happens to be all solved. It's negative 2 and positive 3. So you're done right there. When you see an or, you know that it's like the seal that we did in class when we stood up and we pointed our fingers out and we went or. It's going out. So again, open circle, point it out, closed circle, point it out, and now just bring down your numbers, negative 3, negative 1. Okay, in most cases you'll have to solve these equations, but those two were just to remind you of the graph. So on this one, it's not a complex inequality. There's only one sign, just that greater than sign. So I go ahead and treat it like problems where I'm gathering my x, solving. So I subtract x. We have 3 minus 2x is greater than negative 5. I'm sorry, that is my dog barking. I'm going to see if he'll stop. Okay, now to get the x by itself, we subtract 3 from each side. We get negative 2x. The reason I did not take that negative 2 before the 3 is that the negative 2 is being multiplied by the x. The 3 is actually being added there. Negative 8, divide by negative 2, and we get that x is greater than 4. To graph that, you'd simply show the number line with 4, the open circle, go in that direction. This and this will match as long as your variable is on the left-hand side. So that's why I always tell you to put them on the left-hand side. Okay, here's a complex inequality. We see it's an open circle. We see it's an open circle. We connect it because we don't see an or in there, so we know that it's a hug. Now we go ahead and we solve it. This is like a complicated teeter-totter. There's our creepy dude. We need to get him alone. First thing we look at is what's being added or subtracted. There's a plus 11, so we subtract 11, but this time subtract it from all areas. So it's negative 12. It's less than 2x, less than 8. Now we divide by 2 to get that x alone. That's always our goal, is to get the creepy dude alone. And we end up with x is less than 4, and it's greater than negative 6. So we bring down a negative 6 and a 4, and that's our answer. Now I would like you to write that a little bit clearer for me, just so that I can see it when I'm grading all the tests and I don't get confused. Okay. On this one, again, we see a closed circle. There is no or, so we know that it's connected to an open circle. Now we draw the lines to solve. First thing we want to do is do the add subtract to get the x alone. We add 5 to each side, and we get x is less than 8, and it's greater than or equal to negative 5. Just bring those numbers and that answer right down to your graph. Okay? Next problem is an or problem. On the OR problems, remember the arrows go out. It's like the seal that walks along with his flippers pointed out going or. So we have an open circle, going to point it that way. A closed circle, we're going to point it that way. Now to get the x alone, we add 3 to each side. We get x is greater than 5. Bring that down. On this side, they're like 2 separate problems. Subtract 4 to get the x alone, and we see that x is less than or equal to 3. And there's our answer. Circle those, and circle that. Okay. Next problem, another OR. We have an open circle down here. We have a closed circle up there. Get the x alone, we need to add 1 to each side. So we have 3x is less than -4. Divide by 3 on each side, we get x is less than -4/3. Over here, we subtract 5 from each side. We get 2x is greater than or equal to 4. X is greater than or equal to 2 because we divide by 2 on each side. So that's our answer, and these are our answer. Okay, down to identifying the domain and range. Remember domain we called demand, and demand comes first in every couple. He's just more independent and likes to be the leader. So the first in each couple is -4, -2, 0, and 2. Those are all in order, so we just come down here and do a set symbol, and we actually put them in that order. -4, -2, 0, and 2. Now for the y's, we have 1, 3, and 2. The y is the range, and it is dependent on the x, so it's always following the x. We do want to put it in order though, and you notice how we have 2 1s. Never list them twice in the set because they are the same number. So it's 1, 2, and 3. Okay, tell whether the following relation is a function and explain. It is a function if x does not repeat itself with a different partner. So we look only at the x's to determine if it's a function. We have a -2, -1, 0, 1. Oh, -2, he is repeating himself. So we need to look closely where he repeats. When he repeats, is he cheating? In other words, is he coming with a different y value? Here he has -2, -4, and when he repeats, he's with that -4 again. So he is not cheating. Because he's not cheating, it is a function. So it is a function because x is matched with one and only one y value. He can't cheat. Okay? Show examples of each item. I'm assuming that goes with the next page, which it does. So it says, show an example of a function. A function is any time that we have partners here that don't cheat. So let's just go -3, 5, -2, 1, 0, 6, and let's go 1, 4. So we look at our x's. It doesn't repeat, doesn't cheat. Now here, we want to show that it's not a function. So let's take those values and just make them not into a function. We could have -3, 5, -2, 1, 0, 6, 1, 4, but now to make it not a function, we need to take one of these x values and cause it to show up again with a different partner. So I'm just going to grab this -3 down here. Doesn't matter which one you grab. And instead of showing up with a 5, I could choose any number. Let's say he shows up with a 2. Now we've got an x value that's occurring twice with different partners, so that's not a function. When we map these, we do just like before. We list the domain or the x values on the left and the y values on the right, the range on the right, and we don't repeat them just like we did before. We just list them once. So -3, -2, 0, and 1. Okay, so, whoops, I'm sorry, we should list these in order as well, which would be 1, 4, 5, 6. Now, -3 is matched with 5. This is called mapping. -2 is matched with 1. 0 is matched with 6. And 1 is matched with 4. Now, I want to show you one other thing. Let's say that we have a y value cheating. Let's say that we have, let's give us another x value. Let's say we have an x value of 2, and he shows up with 6. So now we have a y value that cheats. Would list 2 here, and he would be drawn to the 6 there. That is still a function. We don't care if the y's cheat. We don't care if the range cheats. It's only the domain that we're worried about. So when you have 2 lines to one number over here, it's still a function. What determines that it's a function is that there's only one line to each of the x values. Now, let's look at what happens with our not a function. We have -3, -2, 0, and 1 as our domain values, our x values. And we have 1, 2, 4, 5, and 6 as our range values. Okay? So when we match those up, -3 goes to 2. -3 also goes to 5. Right there, it becomes not a function. You could go ahead and match the others, but that has determined it's not a function right there. We have -2, 1, 0, 6, and 1, 4. When we map these, what we're looking at is when it's not a function, here at -3 we have a +2 and a +5. They're on the same vertical line. That fails what we call the vertical line test. A function cannot have 2 points on the same vertical line. So when this one is graphed out, it would be like this. Sorry, I didn't really look down at my graph when I chose these points. So, but as you can see, it goes something like that. So there's never a line where the vertical line touches 2 points at one time. Okay? Here we're graphing. Make sure and go back and see the instructions when I taught this. First thing you look at is your y-intercept. Find that on your y-axis. Next thing, you change the number in front of the x to your slope. This would be a -1 over 1. So you rise 1 and you run 1. Because it's negative, you run to the left. So from that point, you rise 1 and run 1 to the left. There's your 2 points. And you graph the line. Please always use a ruler. I've got them in the classroom. Make sure that you're using a straight edge. You can use the side of your phone or anything for those. Okay, this one, y-intercept, +4. We rise 1, run 3 to the right because it's positive. So we rise 1 from that point, 1, 2, 3 to the right. And there we have our line again. Okay, piecewise functions. Remember, these are the pieces of graphs functioned on one graph. So f of x is the formal name for y, or you can just mark this as your f of x axis. Either one works. Again, you go to the f of x axis or the y-axis at positive 3. You have a slope of 1/2, so you're rising 1, running 2 to the right because it's a positive 1/2. So rise 1, run 2. Now, because it's a piecewise function, I say make a real light line for right now. So we just graph a real light line across there. Now we go to our limitation. X is greater than or equal to 0. We find where x is 0, and we come up here on the line where that 0 is. Because it says it can be equal to, we leave that as a filled-in circle. Now, it says greater than, so it's going to be everything to that side of that 0. Go ahead and put our arrow tip over here, and we erase everything that's not within our limitation. That is part of piecewise functioning, or graphing, I should say. Okay, the next one, f of x equals 3, in other words, y equals 3. Remember I said when you only have one variable, you just cut through that axis. So right at 3 on the y-axis, we're going to cut through. It says x is less than -1. Now normally, I would take that and I would just graph a real light line through there. I don't really like doing it where I've got that other line in there. It says when it's less than or equal to -1, here is -1 on the x-axis. So we come up here, because it can be equal, we make it solid. It says less than, it's going that way, so we put our arrow tip over there, and now we erase everything to this side. And that's why I didn't really want to graph the whole line, because we have to be careful not to erase our other line. There's your piecewise function. Last page. You guys are rolling right along. This is systems. Remember, systems are anytime we put 2 or more functions on one grid. So it asks, show all the possible graphical solutions to systems. These are linear systems. So we have a couple options. If these are my lines, I could have them parallel. So I draw parallel lines. That would be one option. Another option is that these two lines actually cross. Another option. Another option would be that these two lines lay right on top of each other. And that we draw by showing 2 arrowheads on one line, meaning we've got them laying on top of each other. Explain whether each is one point infinitely, many solutions or no solutions. Parallel is no solutions. Because remember, a solution is the point at which both lines contain that point, or the point at which they intersect. So this is one solution, and this would be infinitely many solutions. Okay, now oftentimes when we're graphing, those solutions don't come out right on the whole numbers, so we find that it's necessary sometimes to solve using substitution or elimination. Substitution is easiest to use when you have an equation where an x or a y is by itself. Here I don't have that, so go back to the video on substitution and elimination. It was the very last section that we covered, and I instruct real closely on that. But here I'm looking to cancel either my x's or my y's. And I see that in order to get these opposite, I'm going to have to multiply them both. My lowest number is 6. These two are opposites, so it would be fairly easy. I would multiply this entire equation by 2, this entire equation by 3. So let's just do that. 2 times 3x would be 6x. 2 times 2y is 4y. And 2 times 5 is 10. Here I have 3 times negative 2x is negative 6x. 3 times 3y is positive 9y. 3 times 27 is 81. Now I just add these together. The x's will eliminate. That's why we did that. 4 and 9 is 13y. And 81 and 10 is 91. Now I'm going to look to get that y alone. I would divide by 13. Y equals 7. Now I plug that 7 for y back into one of these original equations. I'm just going to choose that first one, 3x plus 2 times 7 instead of y equals 5. 3x plus 14 equals 5. 3x equals a negative 9. X equals negative 3. See me if you're having trouble on following how I did that. Basically, I subtracted the 14 from 5, got negative 9. Divided each side by 3, got negative 3. Over to this one. In order to get these to be opposites, again, I'm going to have to multiply each equation. I like that these have opposite signs, so I'm going to multiply this by 3 and this one by 5. You don't always multiply by what the other one is, but you do want to get your lowest common denominator of those, and that does happen to be 15 for the y's. So 3 times 3x is 9x. 3 times 5y is 15y. 3 times 5 is 15. Down to the bottom one, 5 times 2x is 10x. 5 times negative 3 is negative 15y. And 5 times 16 is 80. The y's will wipe out when we add those together. 9 and 10 is 19x equals 95. Now, I'm just going to take a wild guess and say probably 5 times 19 is 95. Just because I know 5 times 20 is 100. So 5 times 9 is 45. Carry the 4. 5 times 1 is 5, plus 4 is 9, so I am correct in that. X equals 5. I plug this back into one of those equations to get my y value. Doesn't matter which one. 2 times 5 minus 3y equals 16. 10 minus 3y equals 16. Negative 3y equals 16 minus 10 would be 6. Y equals negative 2. Okay? The last problem here, I'm asking you to define the limitations on domain and range. Remember, domain is going across your x. So if we pretend that we're in a little car driving on this x-axis, we look out the windows, we see the graph lines start about there. Because I don't know exactly what that is, I would simply write that x is greater than negative 2. Now, it goes on and on forever up here, so you can either leave it as x is greater than negative 2, showing that there's no limit on the upper end, or you can write it as a compound inequality, saying it goes to infinity and it's greater than negative 2. Either one at this point I'll accept from you. Now, on the y-axis, y is the range. As we drive up our y-axis, looking out the windows of our little car side to side, there's no graph line, no graph line, no graph line, and right here we hit it. That's right at 0. So we have y is greater than or equal to 0. There is no limitation on the top because even though this has a limitation, this does not, and it goes on and on forever. So we can also write this as y is greater than or equal to 0, less than infinity. Thank you very much. That's the end of our review for the Unit 1 test. Good luck on the test, and we'll see you in Unit 2.